Welcome to the demonstration on the trace store feature by ECB field. This feature is very useful as it allows you to monitor the changes in the values of the predefined ECB fields when a problem set to occur due to a change in an application program or a particular event in runtime. This you in quickly resolving your problem with ease. This trace to type is said to be very useful when you actually know the values that are being changed and would like to reproduce the problem. That is so that you can locate the programs or functions or operands that have caused the change in the field values. Before going into the demo, I would like to recall on the basic prerequisites for triggering this trace store. First is that you should himself or herself connected to any available tests. The trace resource should be visible. You could see we have already resources mapped to the system, and I'm already connected to VPAR 9. So let me open this ALC terminal, and this trace tab is a contextual tab that gets enabled. Under the trace options, click on the trace store. The first case we are going to show from here, we are going to select the ECB field. That is, we are going to now monitor the ECB field values for the specified parameters. That is, so you could see like for the trace to ECB field, you have a lot of ECB field groups. So all these groups are nothing but the tabs that are being displayed in your graphical ECB window. So these are the what you call the fields that have been most frequently visited by the user to debug. You can select any of this field and the corresponding values get populated in the ECB field, and these are the values that are system generated and are read only, and these are populated based on the selected ECB field. This can be hidden or shown by clicking this expand and collapse control, and this is the watch length that helps you to define the length up to which you would like to monitor the changes in the values of the ECB field. So let me keep it as 8. So now I'm going to monitor my ECB field EBW for a watch length of 8. So this is the scenario that I'm going to deal with in this demo without using the compare data and masking abilities. So I've now set all my parameters. I'm going to click OK to confirm my settings, and then I'm giving the application entry and hitting enter. You could see whenever there's a change, the values for the specified watch length, that is 8 bytes, the ECP will get trapped. This can be more evident when I take you like change this 8 bytes, the ECP gets trapped when there is no more further changes for the specified watch length. The tracing comes to an end and the output will be displayed in your ALC terminal. So let us move on to see the next case, that is with the compared data. How is it different from the typical trace store functionality is that this here the trace store feature will get triggered when the selected ECB field value matches the exact compare data that's been specified for monitoring. To enable compare data, I need to check this. So you could see this compare data and the watch length are dynamically generated. So as I change this length, the compare data also get values gets changed dynamically, and you could see that compare data is mainly useful when you like to monitor the value at byte level or character level. So let me give you a value, say E2, and I'm not enabling a mask, so I'm just with compare data and with the exist specified parameters. I'm clicking OK, and I'm going to again give this application entry. You could see that only when the ECP field exactly matches with the compared data that's been specified for tracing, the ECP will get trapped. You could see that in the we have specified the compared data as E2 for a watch length of 1 byte. So here, once you get that value, the ECP gets trapped. You can continue to trace, and base as long as the compare data exactly matches with the changes in the value, the ECP will get trapped if there's no more changes. And as I told you earlier, it will Tracing will be ended and the corresponding output will be displayed in your ALC terminal. Let us move on to see the third case, that is with the mask feature. How is this mask different from the compare data? And the typical workflow is that only when the ECB field value matches a value which is the outcome of the AND operation of the compare data and the mask values, only then the ECB will get tracked. So I've given now a 80 as the masking value and I've written the same compare data and the watch length. Let me click OK to confirm my setting. You could see an alert opens when you're doing a comparison at a bit level. To continue with this operation or to ignore this alert, just click continue anyway. If you would like to stop here and correct any values, click this option. And if you like to close this pop-up, you can click cancel. I'm going to click anyway to continue it, and I'm going to give the same application entry. So you could see that ECP will get trapped only when the ECP field value matches an value which is the outcome of the AND operation of the compare data and the masking values. Okay, and I can continue to trace as long as there's a match or there's a change. So let me click run to trace. Also click F10. Okay, so when there is no more further changes, the tracing gets stopped, and as I told you earlier, the output gets displayed here. Similarly, you can monitor for other possible scenarios by ECP field. The cases are monitoring the EBX field for a displacement of 32 and a watch length of 2 byte, monitoring the data level values, right? So you can monitor in a several ways if you know already the values, and then you can locate the corresponding programs, the operands and the functions. That's all in terms of the trace store by ECB field. Thank you.